Alright, so to let everybody know, I am videoing this, so please don't make me do bad things. Alright, baseball diamond is in the shape of a square with sides 90 feet long. So if you're playing baseball, your baseball is, the diamond from base to base is actually a square, where everything is a right angle. And we know these are 90 feet. That's 90 feet. That's 90 feet. That's 90 feet. Players running from second base to third base. So here's second. Here's third. Here's your player. So he's heading this way. And his speed is equal to 28 feet per second. And they said he's 30 feet. So at whatever point we're at, we got 30 feet there. He's already gone 60 feet. So if we label everything completely, that's what we're getting at. And we want the distance from home plate. How is that changing? So we're actually want to talk about this distance right here. So if we calculated this, and if you take a look at this section right here, and I'm just going to kind of rotate it a little bit like that. There's home. There's the player. There's third base. There's the distance between the player and home. And we're getting into the habit now of calling it S because S is a position function. So now my big question is, what type of shape is this? Right triangle. So I can call that X, I can call that Y. You can call it A, B, C, D, whatever you want to call it. The player's running this way. This is a fixed 90 feet, but we'll put that in. Remember, related rates, what do we do first? We go abstract, which means we don't plug in any numbers. So the one rate that I do know is dy dt. That's equal to 28 feet per second. But is y getting bigger or is y getting smaller as this player is getting closer to third base? Smaller. So is it going to be positive or negative? Negative. And since I wrote really tiny, I have to put a tiny negative sign in there. All right, so right triangle. Do we have anything to do with the angles? No. So the only other thing we can do is, okay, so what theorem? The Pythagorean theorem, which would be what? X squared plus y squared is equal to s squared. So I'm going to move this up since we have a better picture of what's actually happening. Obviously, this is not the Detroit Tigers because they wouldn't have had a guy at second base. Well, no, I'm just speaking truth. That's all that is. Take the derivative of this. Derivative of, hopefully by now we've seen when we have a right triangle problem. And I would think that maybe there'd be a right triangle problem. What's the derivative of x squared with respect to t? 2x times dx dt plus, what's the derivative of y squared with respect to time? 2y times dy over dt. That's equal to s squared with respect 2s times ds dt. All right, now, if I examine this a little bit further, is the distance between home plate and third base changing ever? No. So the rate of change of that distance is 0. So what happens to the 2x dx dt? That's going to be gone. You could divide everything by 2, but I mean it's neither here nor there. You're still going to get the same answer. Because between home plate and third base, that's always going to be 90 feet. So the change is there's no change. There's no change in that x value. So there's no change in the length of the base, or the base path. Now, do I know, I'm just going to keep the numbers here and plug in everything that I know. Do I know 2? Well, what can we do with our 2's? Just divide them out. It'd make it easier. Do I know y? At that point, it's 30 there. So I know it's 30 times negative 28 feet per second is equal to s. Oy, we didn't find s. Do I know x and y though? Yeah, so I can go back to x squared plus y squared equals s squared. What's the base length? 90 feet. So it'll be 90 squared plus the distance the player is from third, which is 30 squared, which is equal to s squared. So s is equal to the square root of 90 squared minus 30 squared. So s is equal to... I didn't put a minus. And I videotaped it. You could go back and prove that I screwed it up. Honestly, it's because I'm so used to subtract something from one side. Sorry. Nice catch. It's good to see you guys are paying attention. And I just rewrote the same thing over again. All right, so what's the answer? 94.86? All right, so you say 94.8683. Going to 4 decimal places is probably good enough. So this is going to be 94.8683 times ds dt. So what am I going to do with that 94.8683? Divide 94.8683. Now, we would probably want to use the square root of whatever number is in there, because that would be the exact answer. And if we were doing something like that, I just want to show this to you so you know what you're doing. What you would do is you would take your calculator and you would say, I want the square root of 90 squared plus 30 squared. And then I get out of the square root and I want to store that answer in A. Once you get done with the expression that you're trying to find, you hit control variable. And above it, it says stow with a arrow. That means you can store it. And if you look at your keypad underneath it, there's 23 different boxes basically that you can store things in. So I'm going to store this in A because that's what I want to do. We don't use X, Y, and Z because we use those for variables. You hit enter and you get 30 times the square root of 10, which if I did 30 point times the square root of 10, there's your 94.8683. So now I always have that in the problem, because now what I can do is hit control variable, control and then 2 keys over. now all I have to do is go 30 times negative 28 divided by A, because A is the actual number of what we're using in this case. Hit enter. I don't like that, so I'm going to go 28 point, because I didn't like getting a square root and a fraction and all that, because it doesn't really make a whole lot of sense. We want a number that makes sense. So now by dividing by that 94.8683, we got ds dt to be equal to negative 8.85438 feet per second. Now, one of the big things is we have to analyze this. What is S in the problem? It's the distance between the runner and home plate. Now, does it make sense, or what does a negative rate of change mean to S? What's happening to S because ds dt is negative? Yeah, so S is decreasing. Now, does that make sense that the distance between... Basically, think of it like this. If you're here and you're throwing a ball, does it make sense that this person's farther away than a person over here, than a person over here at 90 feet? Yeah, because this distance is 94 feet, almost 95 feet. But when he gets to the bag, how far away from home plate is he? 90 feet. So that distance is getting smaller. So S is getting smaller, so we expect it to be negative. And being able to tie that in and understanding that, all right, if ds dt is negative, then this is getting smaller. And I want to make sure that you guys can understand that idea from this. Because if you can interpret your results, the results are one thing, and it's important for the results, but honestly, the biggest thing you want to be able to do is interpret what you get. You want to understand what these numbers mean once you get them. So by taking just that moment and saying, all right, S is the length, it's getting smaller. And that makes sense because eventually when he gets to third base, he's only 90 feet away, but right now he's 95 feet away. Any questions on that one?